Hey, it's no big secret that volcanoes can build new lands. Let's take the Hawaiian Islands for example. They were the result of underwater volcanic eruptions that pumped out molten rock. It reached the surface of the sea and formed land masses. But did you know that the Earth isn't the only body in our solar system with volcanoes? With technological advancements, we were able to explore, from afar, parts of the universe and discover volcanic activity on both planets and moons. Granted, some of them have been inactive for millions of years, but others are spewing all sorts of things into their atmospheres. Most volcanic eruptions found on both moons and planets formed millions of years ago, when our solar system was still a baby and all cosmic bodies had higher internal temperatures. Now, when we think of the term active volcano, we usually associate it with the ones on Earth that are currently erupting. It's easy because we can observe them closely. Beyond our planet, the luxury of studying volcanic eruptions wasn't available until the invention of powerful telescopes. Some were even transported closer to other planets and moons to get a better look. The most direct way to get evidence of volcanic eruptions is to see or capture them in action. The other way is to observe the body's surfaces. An outburst can cover the ground with debris, or it can cause a resurface. Without such studies, it's almost impossible to know if the volcanic activity is recent or millions of years old. Volcanoes, as we know them, are mostly mountainous openings in the Earth's surface that emit volcanic ash, lava, and gases. Celestial bodies that are closer to the Sun have a more solid composition and produce silicate rock lavas just like Earth. However, planets and moons beyond Mars are filled with gas and silicate rocks. These have cryovolcanoes. Instead of hot molten rock, they spew cold liquid or frozen gases such as ammonia, methane, and water. Based on studies, only 4 bodies of our solar system have been proven to have active volcanoes, and only one of them is a planet. The planet is our Earth. The rest of them are moons. We have Triton, Neptune's largest natural satellite. Then there's Enceladus, which is Saturn's 6th largest moon. And the most troubling one, Io, which belongs to the Jupiter gang. It holds the title for the 4th largest moon in our solar system. Let's start with Io, which recently made some news. Io managed to scare everyone by making them believe there was a black hole on Jupiter. NASA's Juno spacecraft snapped a series of detailed images of the planet back in 2012. During the latest approach, which took place this year, it pictured a huge black spot on the ring planet. At first, everyone was shocked, but as it turned out, it was Io's shadow being cast on the surface. The spacecraft was approximately 5,000 miles away from the planet's surface, but it just so happened to capture an eclipse. Due to Io's distance from the Sun, it's hard to imagine that it has active volcanoes. But because of its small volume, it's influenced by the planet's gravity. This gravitational attraction causes powerful pulls, which result in strong internal tides. These are followed by inner friction. The moon heats up, and volcanic eruptions occur. Io has hundreds of volcanic openings. Some of them blast frozen vapor, lava, and so-called volcanic snow. It was also hit by asteroids, just like other bodies in our solar system. But the impact craters keep disappearing because of the eruptions. The volcanic material spills onto the surface of the moon, covering and resurfacing different parts. That's the evidence of volcanic activity. In August of 2014, NASA showed some images of volcanic eruptions that occurred on Io between the 15th and 29th of August in 2013. They were gigantic eruptions, projecting hundreds of miles above the surface. Oddly, only Earth and Io can spew hot lava in our solar system. Now let's get to the king, Triton. This is the largest natural satellite of Neptune and the first place where cryovolcanoes were observed. In 1977, space probe Voyager 2 detected a long cloud of smoke filled with nitrogen gas and dust. It erupted from the moon and traveled 5 miles up in the air. These eruptions happen quite often, and Triton's surface became soft. Here's how it goes. The cryovolcano eruptions fall back onto the surface, creating a soft layer similar to snow. Researchers believe that radiation from the sun goes through the surface of the moon and heats up the underground layer. Then heat gets trapped and vaporizes the nitrogen that lies below the surface. That results in the expansion of nitrogen, which then erupts through the icy layers. The third active cryovolcano is on Enceladus, one of the natural satellites of Saturn. In fact, this is the best documented active volcano. The first activity was recorded in 2005 by the Cassini spacecraft. It captured jets of icy particles coming out of the South Pole region. Cassini even managed to fly over the volcanic cloud and reported that it was composed of water vapor, small amounts of methane, nitrogen, and carbon dioxide. There's a theory that explains how those specific cryovolcanoes work. Below the satellite surface, there are pockets of pressurized water. It remains in liquid form because it's warmed up from the interior. Occasionally, the pressurized water comes to the surface and produces a cloud of water vapor alongside ice particles. Cryovolcanoes hadn't been discovered until 2005, so an extensive search in our solar system was limited. While not yet proven, there's a lot of evidence out there hinting at active volcanoes elsewhere in the solar system. Take Venus, for example. There's a lot of action going on there. It's the hottest planet of the group. It has over 1,600 large volcanoes and 100,000 to 1 million smaller ones. But what happens on Venus stays on Venus, hidden below its thick cloud cover, which is mostly composed of sulfuric acid and carbon dioxide. Well, that's a vacation spot. There's no air or water on the surface of the planet. It just boils off. Venus has an extreme greenhouse effect. Therefore, its temperature can soar up to 880 degrees Fahrenheit. However, it has many layers of different temperatures. The atmospheric pressure slows down the winds. This stops rain or air streams from affecting its surface, which is why old volcanic eruptions look relatively new. The variety of explosions is limited. Only lava comes out, without volcanic ash or explosive molten rock. The tallest feature that resembles a volcano is the Mont Mons. It's 3 miles in height. An orbiting probe called Venus Express recorded some spikes in temperatures that could indicate lava flows. However, it hasn't been confirmed if it's an active volcano. In 2015, scientists working with NASA's New Horizons mission collected high-resolution data of one of 2 cryovolcanoes on the surface of Pluto. They're 90 miles wide and 2.5 miles in height. If scientists are correct, they'll be the largest cryovolcanoes outside of our solar system. For the time being, they were given the name Wright Mons to honor the Wright brothers. Another possible volcano was mentioned in a 2019 study. Scientists from the European Space Agency, NASA, and the German Aerospace Center might have solved how the Ahuna Mons was formed. This is a mysterious mountain that appeared on the surface of Ceres, the largest object in our asteroid belt. It's believed to be a cryovolcano that gushes plumes of salt water and mud onto its surface. Ahuna Montata. It means no worries. No lava. Mars also had a few volcanic features in the Tharsis Montes region. The largest one is the Olympus Mons. The mountain was formed because of repeated volcanic eruptions on the planet. This was, in fact, the biggest volcano in our solar system. It stands 16 miles high and is 374 miles in diameter. To put that into perspective, if you were to put Olympus Mons next to Mount Everest, well, Everest would seem like a molehill. The gigantic highland is a slightly sloping shield volcano. From the side, it represents a warrior shield laying on the ground. That's how the name was inspired. Speaking of inactive volcanoes, Mercury had a time. It's now filled with craters, and as far as volcanic activity goes, nothing interesting happens. But in the distant past, things were more exciting there. There were huge stretches of land masses that formed as a result of liquefied rock spreading across its surface. When the planet began to cool down, those volcanoes went extinct. A huge area of the Earth's moon is also covered in ancient lava flows, but it's no longer volcanically active. Those areas are called mares, which means seas in Latin. The somewhat darker-looking areas remain from previous magma streams that spread on the surface before they cooled down. Mare Tranquilitas, the Sea of Tranquility, was where Apollo 11 first landed. Lastly, we have the largest moon of Saturn, Titan. It's the only identified moon with a dense atmosphere. It's also the only extraterrestrial body with lakes. But it doesn't contain water. It's made up of liquid hydrocarbons. One of the famous mountains there is the Dune Mons. However, there's still some debate as to whether it has active volcanoes. If it does, they'd be cryovolcanoes. Astronomers suspect that more volcanic activity will soon be discovered on the moons of icy planets in our solar system. These include Europa, Dione, Miranda, and Ganymede. They'll likely be so excited with the discoveries, they'll be over the moon. Hey, if you learned something new today, then give the video a like and share it with a friend. And here are some other cool videos I think you'll enjoy. Just click to the left or right, and remember, stay on the bright side of life.